In Module 3, Lesson 19, we're going to look at unknown area problems on the coordinate plane. So we're starting off with a problem that is looking at the area of a parallelogram. The coordinate plane contains figure P, which is a parallelogram, ABCD. ABCD. We're asked first of all to write the ordered pairs of each of the vertices next to the vertex points. Now, so that our diagram doesn't get too cluttered, I'm going to write the ordered pairs of each of those vertices in a list below. So we can see then the ordered pairs for A is -3, -4, B is 0, 2, C is 5, 2, and D is 2, -4. Next, we're asked to draw a rectangle surrounding figure P that has vertex points of A and C. So we're going to draw a rectangle like so, and label the two triangles that are formed as S and T. Then we're asked to find the area of the rectangle that we just formed. And so the area of this rectangle, the base is 8, and the height is 6. So the area of that rectangle is 48 square units. And then the area of each triangle, the area of a triangle is 1/2 times base times height. And the base and the height have to be perpendicular to each other. So when we look at triangle S, it doesn't really matter which one we call the base and which one we call the height. These two sides are perpendicular to each other. So we have 1, 2, 3, 1/2 times 3 times 6. And it is the length of the segment, not the number of squares. So we're going 1, 2, 3, 4, 5, 6 units in length. And 1/2 times 3 times 6 is 9 square units. And this is for triangle S. Just to be certain, I'll look at triangle T and see if it has the same measurements. 1, 2, 3, that's the same. 1, 2, 3, 4, 5, 6. So it is the same. So each triangle is 9 square units. And then we can use these areas to find the area of parallelogram ABCD. Well, we have a rectangle, and then we have these two triangles. So if we subtract the two triangles from the rectangle, we can find the area of this parallelogram. So that would be 48 minus 2 times 9, which is 18, because we have two triangles. And the area would be 30 square units. In our next activity, we're looking at a coordinate plane that contains figure R, which is a rectangle that has the same base as the parallelogram we had before. We're going to draw triangles S and T next to R so that we have a rectangle that is the same size as the one we created on the first coordinate plane. So what I'm going to do is draw the two triangles on this side. to create a larger rectangle that is actually the same size as the one we created on top. And we're asked to find the area of rectangle R. So rectangle R is 1, 2, 3, 4, 5 units by 6 units, and it is 30 square units. And then they ask us, what do figures R and P have in common? Well, they both have the same area. And they have the same area because they share the same base and height. And we don't want to miss that point. They're the same area because they share the same base and height. So now we'll do a little practice. In exercise 1, we're asked to find the area of triangle ABC. The formula for the area of a triangle is 1/2 times base times height. So we have 1/2 times our base, 1, 2, 3, 4, 5, 6, 7, times our height, 1, 2, 3, 4. So 1/2 times 7 times 4 is 14 square units. And the point we want to make is the formula is 1/2 times the base times the height, and the base and the height must be perpendicular to each other. In this case they are, because we have a right triangle. But when we look at other triangles, we will have to make sure that they are perpendicular, or that we have a height that is drawn perpendicular to the base, or the formula will not work. It is not side times side. So please be careful when you are using the formula for other triangles. Our second problem is quadrilateral ABCD, and you may recognize this, hopefully you recognize this, as a trapezoid. They're asking us to find this area 2 different ways. So the first way could be to cut our trapezoid into a rectangle and 2 triangles and find the areas of each of those. So we'll do that first. And my rectangle in the middle is 2 by 5. Two by 5, which is 10 square units. And then triangle, well, we'll have to label this one, triangle 1. Triangle 1, which is on the left, our formula would be 1/2 times base times height. So A, which is 2, times our height, because it has to be perpendicular, 1, 2, 3, 4, 5. And 1/2 times 2 times 5 is 5. Again, they are square units. And triangle 2, the formula would be 1/2 times 1 unit across times, again, 5. Remember, the base and the height have to be perpendicular to each other. So this diagonal line means nothing to us. And 1/2 times 1 times 5 is 2.5 square units. And then finally, in order to find the total for this trapezoid, we would add all three together, and our total would be 17.5 square units. Just want to fit it on here. So this is our first method. Our second method would be to actually use the formula for a trapezoid, since this is a trapezoid. So the formula for a trapezoid then is 1/2 times base 1 plus base 2 times the height. Now let's look at this formula. What we're doing is we're adding the two parallel bases. Base 1, base 2. It doesn't matter which one is 1 and which one is 2. It is the two parallel sides of a trapezoid. Taking 1/2 of that and multiplying times the height. And the height has to be perpendicular to the bases. So in most cases, the height is going to be drawn in so that you can find out the length of a segment that's perpendicular to the base. Now with this formula then, we'll substitute 1/2 times base 1, which is 1, 2, 3, 4, 5, plus base 2, which is 2, times the height, which is also 5. And then when we do that calculation, we get 3.5 times 5, which is 17.5 square units. So the calculation is shorter with the formula for trapezoid. But if you don't remember it, you can always cut your trapezoid into triangles and rectangles and find the area that way. Next, we have a problem where we're given the area of quadrilateral ABCD, and they want us to find its height. So we need then to take the formula, which is base times height, is equal to area. So our base, which we do know, is 1, 2. 2 times x equals 12. And we find x, and x is equal to 6. These are regular units, not square units. Make sure you have that one clear. Then we have a triangle, and they've given us the area of the triangle. So again, our formula for triangle is 1/2 times the base times the height. Now the base we don't know. The base is going to be the length of line segment BC, not the extension of BC. And then times our height, and that we do know the height is 1, 2, 3, 4, 5, 6, 7. We'll solve and then we'll talk about this. Since this is all multiplication, we can use the commutative property to multiply 1/2 times 7 first. That's 3.5 times line segment BC is equal to 14. And then to solve, we'll divide both sides by 3.5, and we find that line segment BC is 4 units long. Now let's just go back and make sure we're clear about where these numbers come from. In order to find the area of a triangle, remember, you have to have a height that is perpendicular to the base. Now this particular height is being drawn from of course, the tallest point of the triangle, and when it drops down to make a perpendicular line with the base actually has to be extended in order to meet that line segment. But the extension of the base is not included in the length of the base. Okay, so in short terms, you take the length of the base times the height, but the height has to be drawn perpendicular to where the base would be. So although we had to extend the base to show that it's perpendicular, this section is not included in the calculation. Next, we have an interesting problem which is, as a matter of fact, our last problem. And this is very interesting for several reasons. The first one is clearly they've inscribed this triangle in a rectangle. And at first glance, you might think, why are they bothering to do that? There's a triangle here. But if you recall, we cannot find the area of a triangle unless we have a height that's perpendicular to the base. Looking at this triangle, although we might want this to be a right angle, it is not. You can prove that by taking a corner of a piece of paper and sticking it inside that angle, but I guarantee you that the paper is going to cover up this other side of the triangle. It is not a right angle. Neither is this, and neither is this. And there is no base that's actually drawn, and there's no way to find our height that's drawn, and there's no way to find that height because this triangle is sitting on an angle. So we can't just count squares. All of that proving the point that in order for us to find the area of this triangle, we're going to have to find the area of the rectangle that it's inscribed within, and then the area of each of the triangles that are surrounding it, and subtract those triangles from the area of the rectangle. Then we will know the area of this triangle that is inside. So I think, first of all, let's label these triangles 1, 2, and 3. That will help us to talk about the same things. And then we'll need to find the areas, first of all, of the rectangle. The area of the rectangle is 11 by 10, which is 110 square units. And then triangle 1 is 1/2 times 7 times 10. And that is 35 square units. Triangle 2 would be 1/2 times 4 times 5, which will give us 10 square units. And then triangle 3 is 1/2 times 5 times 11. Which is 27.5 square units. Now finally, we'll need to subtract the 3 triangles from the rectangle, and we'll get 37.5 square units. So in closing, we want to discuss several of the vocabulary: quadrilateral, rectangle, semicircle, parallelogram, square, diameter of a circle, trapezoid, the altitude and the base of a triangle, the altitude to be the same as the height. And then you, up to this point, should have area formulas for parallelogram, rectangle, triangle, trapezoid, and area of the circle.